welcome you all to the new video here. Today we are going to continue our lecture series on theory of metal cutting. In the previous videos we saw about the manufacturing processes, manufacturing technology and different production technology differences between them. Then we saw the single point cutting tool, the tool geometry, the tool nomenclature, all these aspects of a tool we saw. And we are going to continue our lecture series on the chip formation. So chip formation, what is a chip? It is not like any other chips that is a and it is not like an eatable. Chips here are the removed material from a workpiece. In a simple form we can say that the chips are the scrap materials. So how was these chips formed in manufacturing technology or in a metal cutting process is that purely due to the shear deformation. Shear deformation we may have studied in material science, that is how shear deformation happens. So a metal compresses and flows in a plastic form, so that is called as a shear deformation. The shear deformation is majorly influenced by the shear angle. The shear angle is the angle between the chip and the tool. So how greater the shear angle will influence higher shear pressure, and if it is low, then it will be of a lower shear force. So the influencing factors of chip formation are the material properties, the cutting conditions. That is the cutting conditions. It is the velocity, the speed, then the nature of the cutting tool, the tool geometry, all these affect the chip formation. So I've given a small image on the left. You can see that the chip, how it is the material is removed plastically. Then chip formation, some of the common terminologies are given here. And the cutting tool removes the metal from the workpiece. Those metals are called as chips. As the tool advances the workpiece, the metal is compressed to a compression limit, and then it flows plastically. So that is in other words, the primary shear happens, and the angle, that angle, it is denoted by phi. So that is the shear angle, shear plane. Some other terminologies are chip thickness, how the thickness is calculated. So the thickness is calculated by using the TO divided by TC. That is, TO is the chip formation, before chip formation, the thickness of the chip before chip formation. Then TC is the chip thickness of the chip after the chip is formed. So R is equal to T naught by TC. In the right side we can see an image. So that is the workpiece is given. The workpiece, the blue color box is the workpiece, and the green color is the chip, and the gray one is the tool. So the angle can be defined by the left plane of the tool. So that is the shear plane angle. Okay, so if the shear plane angle is changed, then we can see the thickness of the chip will also be reduced. So T naught is the thickness of the chip before formation, and TC is the thickness of the chip after chip formation. So we can see the thickness of the chip has increased. So some other types of chips. What are the types of chips? So all the chips are not unique or uniform. The chips may be different in different of forms. That is, continuous chips, discontinuous chips, and continuous chips with built-up edges. These are the primary types of chips that can be formed. So it is categorized into these three broad categories. So continuous chips, some example for these chips, continuous chips, it is with an example of a pencil sharpener. We can see when we sharpen a pencil, we'll have that flower-like pattern. The scraps are developed. So that is, it will be whirling. It will be whirling continuously, and the chips will not break. So that types of chips are called as continuous chips. And in some other cases, in some pencils also, same example, in some other pencils we can see the scrap water. When we sharpen the pencil, the scrap will be it will be broken, it will be broken continuously, it will be very small pieces. So that is called as discontinuous chips. And in the same example of pencils, when we sharpen, certain cases we may have the thickness or the layer of the chip formed will not be uniform or the same. The some in sometimes it will be much more bulges or edges that can be formed, that are called as chip continuous chips with built up edges. So I've listed some conditions to produce chips. Some conditions are the material of the workpiece and the material of the cutting tool, both are interchangeable. If at all workpiece is much ductile, then the tools that what we use is harder, then it is continuous chips can be formed. So these are types